Hello guys, welcome to Hardcoder. In this video, we are going to see the Leetcode problem number 766, Toeplitz matrix. Let's get into the question. Leetcode 766, Toeplitz matrix. The problem statement is, given a matrix of m cross n, return true if the matrix is Toeplitz. Otherwise, we need to return false. A condition for being a matrix being Toeplitz is every diagonal from top left to bottom right has same elements. So let's get into the approach, and yeah, we'll get into the approach. So before moving on to approach the problem, so let's define the problem. Yeah, so firstly the input will be a matrix of m cross n. Matrix of m cross n, and output should be true if matrix is Toeplitz or else false. The condition for Toeplitz is nothing but every diagonal that is top left to bottom right should be equal. Every diagonal elements from top left to bottom right are equal. This is the condition for Toeplitz. So what are the corner cases we have to think about? What if firstly we have to check see to yourself that what are the elements in each matrix, or whether it is an integer or long or char. So what type of elements are present in the matrix is the first thing you have to uh, clarify yourself. And second thing is uh, about the corner case. What happens if the matrix has no elements in it? What will be the result of it? So the result for this would be true. Since there is no element, we can say the Toeplitz, whether the given empty matrix is Toeplitz or not, we'll consider this as true. So this is it. And any other things to take care about? Yeah. So yeah, that's all. And now let's get into the approach. So what are the diagonals available? So they are said that diagonals are top left to bottom right. These are the diagonals. So let's consider the given this case. So what are the diagonals available in the given matrix? So the diagonals would be this 4, 5 and 6. So there are 6 diagonals. So we can clearly see that we need to check whether each of the diagonals have same element or not. This is the condition. So our approach is going to be, first step is to check, to traverse each diagonal. Traverse each diagonal. Second step is going to be check each diagonal. Traverse and check. So this should be atomic process. So this only one step. Check each diagonal. So yeah, it's atomic process. So traverse and check each diagonal. This is the only step we are going to do. Yeah, so firstly we'll start with each column, that is each 0 index column. So let's index them 0, 1, 2, 1, 3. These are column indices. 0, 1, 2, these are row indices. So firstly, we'll start with 0 comma 0. So we'll firstly let's say have a pointer I and j. So firstly we will start with each column, so each row. So I and j. So traversing, we'll see I will be 0. Firstly I will be 0 and j will be 0, and we'll have the element as 1, and next we'll increment the j and I to by 1. So we'll go here and check whether previous elements is and current element are same or not. So if it is same, so we'll increment and check whether this element is equal to that element, I mean the previous element or not. So it is equal, so it is proper diagonal, Toeplitz diagonal. So we'll start with other row. So 5 5 it will be true, and 9 it will be true. So we have completely traversed over each row. Now other thing left is each column. So we have checked previously checked the uh, 0 comma 0 index. We started from 0 comma 0 index. Now we'll go with 1 comma, sorry, 0 comma 1. So I will be 0 and j will be 1. So the element is 2, and now we'll increment it. I will be 1 with j. Sorry, yeah, I will be 1 and j will be 2. So 1 comma 2 is, so we'll check it, and yeah, it is same. So check with the previous element, that is in the top left. Yeah, it is same. So we'll increment the I and j. So it will be 3 and 2. 2 comma 3. So 2 comma 3 is this. So we'll check the top left element of the current cell. It is 2. Yeah, it is matching. So we'll increment, and you can clearly see that the next cell will be out of bounds. So we'll start with second column. So we'll start with second column. I will check, and will find if it is a Toeplitz matrix. So we'll start with 0 comma 3 index. Yeah, it is Toeplitz matrix. So in this way we can start with each row and each column and find the Toeplitz condition. If any of the diagonal doesn't form the condition, that is Toeplitz diagonal condition, will return false. So this is the approach. The first approach is to start with each indexes. The second approach will be just to traverse and check a top left element of each index. So how can we do this? So let's take this event test case. So the indexes will be 0, 1 and 2, 0, 1, 2, 1, 3. So we'll go over each element. So we'll go here and see whether the top left of the current cell is available or not. Here it is not available, so we'll continue. So top left will not be available for each of the elements. So we'll continue to move on to next row and check for the top left element. So top left element is not present, so we'll move on to next index. So we'll check whether the top left element is available or not. Yeah, here it's available. Now we'll check whether the current element is equal to top left element or not. Yeah, it is equal. So we'll continue, and we'll check whether top left element is available or not. Yeah, it is available. It is 2. So it is 2 and 2 are matching. So we'll continue. Yeah, here we'll check whether the top left element is available. Yeah, it is available 3, and it also meets the equal condition. So yeah, we are satisfied, and we'll move on to next row. So we'll check whether the top left element is available or not. Here it is going out of bounds, so it is not available. So we'll move on to next column of the current row. We'll check whether the top left element is available or not. Yeah, it is available. That is 5. So we'll check whether they are equal. Yeah, it is equal. So we'll move on to next column. So we'll check whether the top left element is available or not. Yeah, it is available. We'll check, and then it is equal. So we'll move on to next column. So we'll check whether the top left element is available. Yeah, it is available. So we'll move on to next row. So finally we have uh, visited each cell, so you can return true. this is the approach. To first step would be to traverse each element. Yeah, the approach is same, but we are using very simplified way. We are not starting with each of the index and incrementing. We are going to each of the shell and checking the top left element. So let's consider invalid case. So let's copy this. So yeah, we'll edit over this. So indices will be 0, 1, 0, 1, 1. So we'll firstly have start with this index. So we'll check whether top left element is available or not. It is not available. So we'll continue. So the top left element is not available. So we'll increment 0. So we'll check whether top left element is available. It is not there. So we'll increment. So we'll check whether top left element is available or not. Yeah, it is available. And we'll check whether both of the elements are equal or not. 1 and 2 are not equal. Not equal. So we'll return false. So answer of this question is false. So I hope you are clear about this approach. If you are not clear, we'll be very clear in the coding section. Let's get into the coding section. So we'll have a for loop to write it over each places. I mean each cell of the matrix. So we'll the condition for not for top element dot available is nothing but if I is 0 or j is 0, we'll continue. Yeah. uh, yeah, why are we doing this? It's nothing but let's consider this element. This element doesn't have any top left element, and this too doesn't have top left element. So we can clearly see that the elements in 0th row will not have top left element, and the elements in 0th column, that is first column, will not have any top left element, but other elements will have. So this is what we are doing here, and let's check whether we'll take the top left element, which is I minus 1 and j minus 1. If top left element is not equal to current element, which is not y comma j, will return false. And finally, will return true. Will he reach here when we check off the each cell? So it will be a happy case. So I check with sample test case. Let's proceed. Let's submit it up. Yeah, accepted. And the time complexity of approaches are of m into n, and space complexity is constant, which is p of 1. So approaches for this problem is just traversing each cell of matrix. So that's all about this video. Thanks for watching this. Have a great time.